If you've been flying drones for any length of time, you've probably heard the term VLOS, visual line of sight. It's one of the fundamental principles of drone operation. It's mentioned repeatedly in regulations, guidance documents, and discussions between drone pilots. And for years, it's been accepted as the gold standard for safe drone operations. But today, I'd like to ask a question that some people might find uncomfortable. A question that would have sounded ridiculous just a few years ago. Is VLOS outdated? Now, before anybody rushes to the comments section, and please do later on, let me be clear. I'm not suggesting that people ignore regulations, and I'm certainly not suggesting that people fly illegally, and I'm certainly not suggesting that safety no longer matters. What I am asking is whether modern drone technology has advanced so quickly that some of the assumptions behind visual line of sight deserve to be revisited. Let's take a look. Visual line of sight made perfect sense before, and we need to understand why visual line of sight exists. The idea is simple. If you can see your aircraft, you can monitor its position, you can monitor its direction, you can watch for hazards, avoid collisions, and maintain situational awareness. That's entirely sensible. In fact, when consumer drones first appeared, VLOS was arguably the safest and most practical way to operate them. The technology was basic. Obstacle avoidance barely existed. Telemetry was limited. Camera systems were primitive. If you wanted to know what your aircraft was doing, your eyes were often your best source of information. And that made VLOS a very logical safety requirement. But technology doesn't stand still. Let's imagine a drone flying several hundred metres away. At first you can clearly see it. You can identify its orientation. You can see which direction it's facing. You can understand what it's doing. But as distances increase, something changes. Eventually the drone becomes a tiny speck, a dot in the sky. And that raises a question. If all I can see is a dot, am I really maintaining situational awareness? Can I genuinely determine what the aircraft is doing? Can I identify its orientation? Can I monitor its surroundings? Or am I simply maintaining visual contact with a tiny object? And this is where the discussion becomes interesting. Many drone pilots talk about a 500 metre limit. You'll often hear people say, you can't fly beyond 500 metres. But VLOS isn't simply about a number. It's about what you can actually see and assess. The reality is that VLOS varies. A larger drone can often be seen further away. A smaller drone might disappear much sooner. Weather matters, lighting matters, your eyesight matters, which means that VLOS is not a fixed distance. It's a judgment. And that's where modern technology begins to complicate the picture. Let's consider strobe lights. Many pilots, including myself, fit strobes, very small, very lightweight, little lights, to increase the visibility so that I can see it much clearer in the sky. And they work. A powerful strobe, and the ones that I use are powerful, can make a drone visible at much greater distances. But here's the question. If I can clearly see a flashing strobe at 700 metres, am I maintaining VLOS? Or am I simply seeing a flashing light? Can I determine orientation? Can I understand what the aircraft is doing? Can I assess the surrounding environment? Well, it depends. You can have a red light on one arm, a green light in the other arm, a white light in the centre, That would certainly help you to determine the orientation of the drone, let you know which direction it's flying. Now, reasonable people might disagree, but it's another example of how technology has blurred what once seemed like a straightforward concept. Now let's look at a modern drone. Maybe not too modern, but let's look at the DJI Mavic 3, my preferred drone. The Mavic 3 can detect obstacles in multiple directions, display live high-definition video, show its precise location on a map, provide real-time telemetry, automatically return home, and warn of potential hazards. But here's the really interesting part. The obstacle avoidance sensors are cameras, and the Mavic 3 allows me to view those cameras, so I can effectively look all around the aircraft while it's in flight. I can look forward, backwards, left, right, above, below, while flying. I can be flying forward and watching what's behind me. Now think about that for a moment. If my drone is 500 metres away and appears as a tiny dot, which gives me more information? Looking at the dot or looking through multiple cameras mounted directly on the aircraft? Now that's not a rhetorical question, it's a genuine question, because modern drones can provide an astonishing amount of information about their surroundings. Information that simply was not available when many VLOS concepts were originally developed. So let's imagine a hypothetical court case. A pilot is accused of operating beyond visual line of sight. The regulator, the CAA, argues that visual line of sight is essential. The pilot argues, my drone had omnidirectional obstacle sensing, multiple cameras, and a high definition live video feed. It had real-time telemetry and it had automated safety systems. It gave me more information than I could possibly obtain from visual observation alone. What happens next? Would the court place greater weight on the regulator's guidance, or would it be persuaded by evidence demonstrating that modern technology is much better and what it can actually do? Nobody knows. And that's what makes the question so fascinating. Courts generally place considerable weight on expert opinion and regulatory guidance. That's entirely understandable. But courts also consider evidence, and technology continues to evolve. The question isn't whether somebody would win that case. The question is whether such a case may eventually force a re-examination of assumptions that have existed for many years. Now let's talk about safety, because ultimately that's what all of this is about. Modern drones are becoming safer, not less safe, safer. Obstacle avoidance systems are improving. Navigation systems are improving. Return to home systems are improving. Aircraft awareness systems are improving. Automation is improving. So here's another question. When we look at the safety record of modern drones, how much of that success is due to pilot skill and how much is due to technology itself? Because if technology is increasingly responsible for maintaining safety, then surely that has to be part of the discussion. So, is VLOS outdated? Personally, I don't think the answer is a simple yes or no. The principle behind VLOS remains sound. Situational awareness matters, safety matters, responsibility matters. But I think that modern technology has raised questions that deserve discussion. Questions that simply didn't exist years ago. Today's drones can see more, measure more, monitor more, and in some cases arguably provide greater situational awareness than visual observation alone. The technology has changed dramatically. The question is whether the thinking behind VLOS has changed with it. I'm not sure it has, and I'd be interested to hear what you think. Do you think that VLOS remains just as relevant today as it was when the concept was first developed? Or do you think that modern drone technology has started to challenge some of the assumptions behind it? Please let me know in the comments.